All right, Algebra 1, welcome back, guys. We are officially now moving into section 2 of chapter 5, okay? As you can see on the screen here, we are doing a lot of stuff with functions and graphs, okay? So this whole chapter has a pretty big graphing part to it, okay? Teaching you a couple, in fact, at least a few, maybe 3 different ways of creating graphs. All right, and this section right here is going to cover one of the more introductory basic ways of creating a graph. Okay, so as you see on the screen there, remember that domain goes with the x value, range goes with the y value. So anytime they are to say things like, I gave you a function, basically saying I'm giving you an equation, and here's all your domain values. That's their way of saying here's all your x values. And then they want you to calculate all the range values. What does that mean? Calculate all the y values. All right, you remember back in the last section, in the last video, if they say here's your domain, that means here's x, plug it into the equation, and then calculate it and get y, which is your range, out of the equation. All right, so all of these notes right here, guys, it's going to be a matter of you being dedicated and taking the time to read them, follow them, write them down, okay? So that I don't really need to like read all of this to you. You can see what's on the screen here. Given domains, you have to do at least 3 domains, okay? You're going to plot these points. So go ahead and take the time right now to read this, pause the video, do what you need to do to copy that down. Okay, take that time. And then you're going to see that everything related to this note right here, you're going to find in example 1 and example 2. All right, now let's move into the next part of our section. And so let's say they give you a graph. They're not giving you points. Remember back in section 1, they gave you multiple points and said, is it a function? Is it not a function? Well, now in section 2 right here, they are giving you a graph and saying, look at this graph. Tell me, is the graph a function or is the graph not a function? All right. And the key thing you're looking for, again, is still the x values. All right. Look for dots that share the same x value. All right. What you could do is draw a vertical line, which you're going to find and see me do in examples 3 and 4. That's going to be helpful to understand from a graph, is it a function? All right. So speaking of example problems, let's jump in and do some right now. Here goes the example problems. So first thing just says graph. There's your function. All right. Your function is this guy right here, 2x minus 1. There's your function. Here's all the domains. I'm giving you domains. There's -3, -1, +2. Domains, remember, what are they? Domains are your x values. So if I give you the x values, what do you need to do? You have to plug those x values in right here for x into the function and then get all the y values out. So let's start that process. Y equals 2, parentheses, -3 minus 1. Y equals 2, parentheses, -1 minus 1. And y equals 2, parentheses, +2 minus 1. All I did is plug those domains in for x, and now we need to see what comes out on the other side. So let's do this first one right here. 2 times -3 is -6 minus 1. So y equals -7. Now the second one, 2 times -1 is -2 minus 1, -3. Now, y equals 2 times 2, that's 4, minus 1 equals +3. So here's what I'm going to show you now. Now what we have are actually 3 points that we can plot on the graph. Where did I get that -3 from? That's the first domain. Then this one, that's the second domain, and there's the third domain. Now I have the y values. I just calculated all of them. -7, -3, +3. I now have 3 points. That's more than enough to plot these points on this graph right here. All right. So we have our x-axis Don't forget the x-axis right here. That's the left and right. The y-axis up here, that's the up and down. Okay? All right. So our first point, -3, -7. We definitely did not have quite enough space for that one. So let's go ahead and extend this down. We got 1, 2, 3, 4, 5, 6, 7. There we go. We're going to cover that space. Perfect. So again, the first point, -3, -7. So we're going to go left 3 times. 1, 2, 3, down 7 times. That's going to have us right here. Left 3 times, because that was a -3, then down 7. So this is our first point right there. Now our second point, -1, -3. Go left once, down 1, 2, 3. There's our dot. Remember, we went left once, then down 3. Okay? And our final point, +2, +3. So we go right 1, 2, then up 1, 2, 3, and we are right there. Now the final thing that you have to do is simply connect the dots. And let's see if Mr. A can do that. Boom. Magically connect those dots and go ahead and put the arrows at the end. There is your graph. It's a straight line. Straight lines are known as linear functions. Linear for straight. Okay? All right. Let's take a look now at our second example problem where we will be graphing a different function. The function is -4x plus 2. And here's the domains, real easy domains, -1, 0, and +1. So step 1, plug those domains in for x. So y equals -4, parentheses, -1, plus 2. Y equals -4, parentheses, 0, plus 2. And y equals a -4, parentheses, 1, plus 2. Remember, domain goes with x. Where do you see an x in the equation? Plug those values in for x. What's the range? The range is the y. So what does this actually equal here? So the y equals for each of these equations. -4 times -1 is +4 plus 2 equals 6. -4 times 0 is 0. Plus 2 is 2. -4 times 1 is -4. Plus 2 is -2. All right, let's go ahead and now create the points because we now have points, right? We were given domains. Here's our first x, -1. There's our second x, 0. There's our third x, 1. And let's plug in the y values. 6, 2, -2. All right. All we have to do is now plot these points on the graph. So let's make sure that we have a proper amount in the y value. We got 1, 2, 3, 4, 5. Okay, perfect. We're good there. So first point, -1, +6. We go left once, up all the way to 6. So we are right there. Next point is 0, meaning don't move left or right. Stay right there at 0, 0. Then +2 means go up 2. So we're right there. Last point, 1, -2. So go right 1, down 2. That means we are right there. And now let's go ahead and connect the dots right here. And put the arrow on it. Boom. There we go. So that is our graph, our linear function. All right. Now, here we go. Final part here. Determine if the graph is a function. So now you're going to see that we have a couple different graphs here. Let's take a look at number 3. Look at those dots. If I were to take a line and draw a line through every dot, All right. Lines going through every dot. Do you see any one single line actually crossing through two red dots? The answer is no, you don't. So that means that this first one is yes, a function. If we found a single line crossing through two red dots, then the answer would be no, it's not a function. So let's take a look at the next one. Draw a line through every dot. Let's see, do we hit any multiple red lines? And we do. We hit multiple red lines twice. All right, let's take a look. We hit them right here, and we hit them right here. So in that case, this is a perfect example of something that we are going to say is no. Sorry, no, not a function. All right, perfect. Let's double check right here. We are good. That covers all the example problems that we needed for section 2. All right, remember, write down your questions, write down these notes, follow along with them, and any questions you have, come to class. We'll take care of that. See you guys in the next one.